Hi, here's another video to help you with proof techniques. Again, for those of you who have not seen proofs, this is intended to help you get a better feeling for what we're doing. So here's something we might want to prove. Prove that there is no positive integer solution to x squared minus y squared equals 1. So when you're trying to prove a statement, the first steps are no different. Remember, our first step is to answer, what is this even saying? What are we trying to say here? Okay, so if I have a positive integer, let's say x is 4 and y is 10. 4 squared minus 10 squared is not equal to 1. Well, that's not exactly what it's saying. It's saying that if I take any x to be any positive integer and any y to be any positive integer, that if I find the difference of their squares, there's no way to get 1. So, in other words, for every positive integers x and y, x squared minus y squared is not 1. So, the other question that you need to answer is, do I believe this statement? Do you actually support this? If you go about trying to prove it, it's going to be difficult to prove if you don't believe it. So make sure you're comfortable with this statement, that you actually believe that if you take two positive integers, that the difference of their squares is never going to be 1. And that might help clarify some of the definitions for you. Let's say you say, well, I think you're crazy. If x is 1 and y is 0, then 1 squared minus 0 squared is equal to 1. What are you talking about? And that might help us clarify, for instance, this word positive. Okay, 0 is not a positive number. It is not a negative number. It has neither sign. So when we talk about positive integer solutions, we mean integers that are 1 or more. So let's go about trying to prove this. We want to prove there is no positive integer solution to x squared minus y squared equals 1. So the difficult part about proving this directly is that if we prove this directly, we're going to have to take every single x and y integers and find the difference of their squares and show that that's never 1. And that's, we can't take every pair because there are infinitely many choices. So a better way to proceed on this is proof by contradiction. So let's talk about the basics of proof by contradiction. What we're going to do is we're going to assume the opposite. We're going to suppose that we have x and y that are positive integers, where x squared minus y squared equals 1. I'm sorry, my son's sitting next to me making funny noises. So if you hear funny noises in the background, that's him. So, back to the proof. We're going to suppose x and y are positive integers where x squared minus y squared equals 1. In other words, we're assuming that the statement is false, that we really do have them. And what we're going to want to do is we're going to try to use facts, definitions, theorems, and then we want to come to a conclusion of something that is really clearly false. Either it contradicts our original assumption or it's just ridiculous, something like 1 equals 0. So that's what we're looking for. We're trying to come to a conclusion where something is clearly false. And after we realize that, we start with assumption and we get to a conclusion of something that's false, we realize, well, this assumption can't be true. And so we would say, by contradiction, x squared minus y squared equals 1 has no positive integer solutions, and then that would be the end of our proof. So let's try it. We're going to start with this assumption, and then we're going to try to only use facts and figures. So what would it mean if we have a positive integer solution such that x squared minus y squared equals 1? Let's use this and see, what would this tell us? Well, what if we factored x squared minus y squared? This factors as x plus y times x minus y, and we would say that equals 1. Now, usually when we're solving equations, we don't factor unless we have 0 on one side, so we can use the zero product property. But we can also use the fact that x and y are positive integers here.
Why is it writing?
Okay, Alex, you need to be quiet. So, what else do we know? We know x plus y and x minus y are integers now, since x and y are integers. Okay, so now we have the product of two integers equals 1. All right, notice that I erased that conclusion that something's clearly false. I just ran out of space, but that's what I want to do there. Make sure you understand this statement. X plus y and x minus y are integers now. So what does that mean? Well, what are the ways that we can find a product of integers that we get 1? They're either 1 times 1 or -1 times -1. Well, x plus y is a positive integer and it divides 1. So that tells us x plus y is 1. And then that means x minus y is 1 also. If we take those two facts together, if x plus y equals 1 and x minus y equals 1, it's a system of equations. And that's very easy to solve. That tells us that x equals 1 and y equals 0. Excuse me. And what's the problem with that? If x is 1 and y is 0, remember that's that solution that we talked about 5 minutes ago, because 1 squared minus 0 squared is clearly 1. That could be our solution, right? Let's not forget this word positive. X and y are supposed to be positive integers. So this is actually a contradiction to our assumption. Y equals 0 is a contradiction to our assumption. And this is the assumption that y is a positive integer, excuse me. So since we assumed that x and y are positive integers, such that x squared minus y squared is 1, and we reach the conclusion that x equals 1 and y equals 0, those two facts do not agree with one another. So we say by contradiction, x squared minus y squared equals 1 has no positive integer solutions. I'm sorry. Please stop bothering me while I'm working. Thank you. Okay. So what do? If we're doing a proof by contradiction, we've got 3 steps here. First, we're going to assume that the statement is not true. Then we're going to use definitions, facts, and theorems to logically arrive at a false conclusion. What would that false conclusion look like? Okay, it could be that the assumption is false, that our assumption that the statement is not true is false, or we could get some ridiculous statement, or just a kind of ridiculous statement, just something that's very clearly not true. And if we make an assumption and we come to a conclusion that's not true, then that assumption also can't be true. And we conclude by contradiction that our original statement must be true.